Raster data is digital images collected by aircraft, drones, satellites, ground and water-based sensors, digital photographs, and scanned maps. Raster data consists of boxes called cells or pixels or grids. These pixels reflect different information, such as image reflectance or temperature, depending on the purpose of producing the data. Raster data can be stored in different formats, but the most common of these is the GeoTIFF format. We can say that the GeoTIFF format has become a standard for raster data. In the ASCII format, raster pixels are shown with numbers. Raster data can appear in three different forms: continuous data, categorical data, and digital photographs. Continuous data represents satellite imagery, aerial photographs, and additionally, physical and environmental data such as elevation and temperature. Satellite imagery and aerial photographs are commonly used as base maps. With the help of base maps, we ensure that the data of objects such as buildings, trees, and utility poles that we use in our projects are spatially aligned correctly with these objects. You can see an example aerial photograph on the left and an example elevation data on the right. Categorical data represents maps divided into different categories such as land cover and soil type. You can see a sample land cover map here. This is an example soil type map. Digital photos are photos such as scanned maps and building drawings. Here is a close-up of an example scanned map. In raster data, each pixel has a different value, and what these values mean varies. For example, on an elevation map, each pixel shows how many meters high that area is, while on a precipitation map, each pixel shows how many millimeters of precipitation fell on that area in a certain time period. Pixel values can be positive or negative, integers or decimals. Integers are useful for representing categorical data, while decimals are useful for representing continuous data. In addition to these, you may also encounter pixels that are shown as no data. This means that we do not have data for that pixel. The size of each pixel in the data, that is, the spatial resolution of the data, determines the degree of clarity in the data. As the pixel size decreases, it becomes easier to see details. High resolution means that the pixel size is small,